Okay, great talk. Any questions for Xiaojian? Rohan.
Hello.
Hello.
Hi. So great talk. And my question is that you say that in CC-NVMe you can decouple durability with atomicity or ordering. So does that mean that you provide lower durability guarantees? And if so, when is durability actually guaranteed to applications?
Sorry, I can't follow you. Could you speak more slowly?
Yeah, sorry. So you decouple durability with atomicity in CCNV, right?
Yes.
So my question is that, does this mean that you provide lower durability guarantees in CC-NVMe? And when is durability guaranteed in this case to applications?
Okay. CCNVMe has a version that does not guarantee durability, but the classic CCNVMe does provide durability because the file system or other storage software would wait for the durability of all in-progress data blocks to be durable. But for applications such as some database applications such as MySQL, some of its operations does not wait for the instant durability, but it can wait for the final durability of all blocks. So I think the separating atomicity from durability could make sense in this case.
Okay, so basically you add a new system call for guaranteeing just atomicity and not durability. Is that correct?
Yes.
Okay, thank you.
Okay, our next question is from Mike Chin.
Hello?
Yes, we can hear you.
But I can't hear his question.
Mike, can you ask your question? Oh, he's muted. So in the meanwhile, anybody else have a question while Mike is solving his audio problems? Okay, Rohan.
Hi, sorry, I can ask one more question. I was wondering if the version of CC-NVMe which provides durability as well as atomicity, can that scale well in general, or is there a fundamental limitation of like you have to compromise durability to get good scalability? Is that a fundamental drawback for NVMe?
Do you mean the scalability of separating atomicity from durability?
So my question is that if you have both combined atomicity and durability, then is the scalability similar to like JBD2 journal of ext4, or is it still better for CC-NVMe?
Okay, the JDB2 journal has severe scalability issues, and
Right.
CCNVMe we developed the M2FS atop CCNVMe, which address these scalability issues. The M2FS details are not presented in the slides, but to fully utilize CCNVMe, we should reduce the software overhead, such as the scalability issues of the journaling to use these primitives.
Okay, thank you.
Your camera and microphone.
Hello.
The first question is from Haoning Lan. Haoning.
Hello, can you hear me?
Yes.
Okay. I'm Haoning from Fudan University. Thank you for your awesome presentation. I have a small question here. To implement CCNVMe, do we need to modify some hardwares or softwares? If so, how much effort do we need?
Thank you for your question. We do not to change the hardware too much. The only change in the hardware is the SSD should enable the persistent memory region feature. This feature is already defined in the NVMe stack since about 2020, and this new feature has not been enabled in modern SSD, but we believe it will be enabled in next generation SSDs because it's a really useful feature.
Okay, I see. Thank you.
卓豪生。
Hi, I'm Zhou Hao. Thanks
Hello.
for your talk. And your work remind me of the previous work on also the crash consistency named OptFS, but it implements this by delayed writes on metadata. Did you compare its performance between your work and OptFS? Because I think the two methods are quite similar, and OptFS uses delayed writes to reduce the flash operations, and you use the doorbell methods.
Okay, thank you for your question. We do not compare OptFS by experiments, but we expect that the performance will be similar because both systems, SysMME and OptFS, use similar optimistic crash consistent techniques. So this assumes that the crash will not happen frequently, and the ordered and atomic transactions can be sent to the device, and if the crash occurs, then using recovery techniques to recover the system to a consistent state. So we guess the difference will not be much different.
Thanks.
Thanks, Zhou Hao. Next question is from Jinyuan Zhang. Jinyuan.
Okay, can you hear me?
Yes.
Okay, I'm Jinyuan Zhang from Peking University. So I want to know that how do you parallelize ordered transactions? If two transactions have order dependency, how to parallelize them?
Thank you for your question. Parallelizing transactions can have two ways. The first way is using the multi-queue parallelism of the original NVMe. That is, applications can queue their transactions to different hardware queues in parallel. But this parallelism should use the techniques proposed by our previous work in OSDI, namely Hori. That the Hori separates the ordering control from the classic data flow and can enable parallel but ordered transactions in different hardware queues. That's the first way. The second way is that in the single hardware queue, we separate the atomistic guarantee from the durability guarantee. So the applications can continuously queue the order transactions to one hardware queue, and if the ordering guarantee is violated after the crash, we can discard. We can inspect that ordering violation and play roll forward, play rollback forward. Do I solve your problem?
Okay, thank you. Thank you for your answering.
Okay, cool. Yang Chen, go ahead. Yang. I think he has some problem on his speech with the audio maybe. So I ask one question is how does MQFS maintain the global order across different hardware queues?
Do you mean the global order among multiple hardware queues?
Yes.
We use a simple way that embeds the global order in the reserved field of the NVMe command and use the global order, for example, the physical timestamp to enforce the order during normal execution or crash recovery.
Okay, cool. I think it's time for the mini panel session.